Going to continue problems under the Newton's divided difference formula. So in the last video we studied one problem under the Newton's divided difference. So this is the second problem. This is very important problem because in this problem we are going to construct an interpolation polynomial, not any value of x. Here we are not going to find any value of x. Here we have to construct an interpolation polynomial in terms of x. For that one, what they given here, observe, construct the interpolation polynomial for the data given below using the Newton general interpolation formula for divided difference. So Newton general interpolation formula for divided difference, it is nothing but Newton's divided difference formula only. Okay, by using this formula we are going to construct an interpolation polynomial. So for that one, what they given here, data x entries and y entries. X entries are 2, 4, 5, 6, 8, 10. Corresponding y entries 10, 96, 196, 350, 868, 1748, 6 respectively here. So before applying the polynomial, before applying the interpolation formula for a divided difference, first we have to construct here divided difference table. Okay, so construct divided difference table. So you know that the divided difference table contains as a first entry is x, f of x, first divided difference, second divided difference, third divided difference here. Okay, so x entries are here 2, 4, 5, 6, 8, 10. Corresponding y entries are, y is nothing but f of x only. So what we have is 10, 96, 196, 350, 868, 1746. So x entries are nothing but x0, x1, x2, x3, x4, x5. Similarly, y entries are nothing but f of x0, f of x1, f of x2, f of x3, f of x4, last entry f of x5. First divided difference must be in between these two. First divided difference, first entry must be between these two, that is denoted as f of x1, x0. f of x1, x0 means f of x1 minus f of x0 divided by x1 minus x0. 96 minus 10 divided by 4 minus 2, 2. What it implies here? 43. Okay. Similarly, second entry in the first divided difference, that is denoted as f of, it is x0, x1, not x1, x0. x0, x1, next entry x1, x2. Okay. Then f of x2, what we have here? 196. This factor must be in between these two. f of x2, 196 minus 96 divided by 5 minus 4, 1. What it implies? 100. Similarly, third entry in the first divided difference is found by again f of, here x1 over, then start here x2, x3. f of x3, what we have here? 350 minus f of x2, 196 divided by 6 minus 5, 1. So 350 minus 196, what it gives? 154. Similarly, f of x3, x4. x3, x4. f of x4 means 868 minus 350 divided by 8 minus 6, 2. It implies as a 259. Okay. Similarly, last entry, it is denoted as f of x4, x5. f of x5 means 1746 minus this one 868 divided by 10 minus 8, 2. So this implies 439. Okay. Similarly, second divided difference. Second divided difference must be in between these two, that is denoted as f of x0, x1, x2. Okay. If here second divided difference, then here 3 factors, x0, x1, x2. It starts from x0 only. Then here first divided difference, then here must be 2 factors, x0, x1. Okay. If your third divided difference, then the factors must be 4. Starts from x0, x0, x1, x2, x3, like that. Okay. So your second divided difference, then factors must be 3. Okay. Then it is found by again in between these two now. So 100 minus 43 divided by last entry what we have here, x2. x2 value 5 minus first entry what we have, x0. x0 what we have, 2. So calculate that one. 100 minus 43, 57 divided by 5 minus 2, 3. So 19. Okay. Substitute here. 19. Then next entry between these two, that is denoted as f of here x0 over na, then start here x1, x2, x3 equals to 154 minus 100 divided by last entry what we have, x3. x3 means 6. First entry x1. x1 means what we have, 4. 6 minus 4, 2. So 154 minus 154. 54 divided by 2. What it implies here, 27. Okay. Next entry between these two, f of here x1 over, then start with x2, x3, x4 equals to 259 minus 154 divided by last entry what we have, x4 na, x4 means 8 minus first entry x2. x2 means what we have, 5. 8 minus 5. Okay. Then solve here. 259 minus 154 divided by, okay, divided by 8 minus 5. So 35. Next entry between these two na, f of here suffix is 2, then here must be 3, x3, x4, x5 equals 2. Okay. This is for this one and it is for this one, it is for this one. Okay. Then 439 minus 259 divided by last entry what we have, x5. x5 means 10 minus x3, 6. So calculate here, then you will get 45. Then similarly third divided difference. The first entry in the third divided difference must be in between these two. That is denoted as x0. Third divided difference means here must be factors 4. Starts from x0, x0, x1, x2, x3 equals 2. Okay. So 27 minus 19 divided by last entry what we have, x3 na, x3 value 6. First entry x0. x0 means 2. So calculate this one. 27 minus 19 divided by 4. 2 only. Okay. 2. Next. F of here x0, then start here x1, x2, x3, x4. Okay. Next. Here 35 minus 27 divided by last entry what we have, x4. Okay. x4 means 8. First entry x1. x1 means 4 equals to 35 minus 27 divided by 4. 2 1. Then last entry in the third divided difference is found by here x1 over, then start here x2. x2, x3, x4, x5. Then 45 minus 35 divided by last entry x5 10, first entry x2 value 5, so 2. Okay, when you are writing these factors now, be careful with that factors, because if you are third then here 4 factors, if you are 2 then here 3 factors, keep it in a mind. Okay, then you can continue 4th and 5th divided difference. Okay, you can continue like a 4th and a 5th. So if you continue 4th divided difference, then 2 minus 2 0, 0 divided by anything again 0. Then here also 2 minus 2 0, 0 divided by any denominator term always 0. 5th divided difference also 0. If we got here same means constant values, here constant values 2 2 2. If there is any variation in these entries, then you have to continue. If you got here same entries, then stop the table here only, because next entry must be 0. Okay, no need to continue here, because here the 4th divided difference value 0 and 5th divided difference value also 0, because here entries are same here. If there is any variation in these entries, then you can continue. Okay, so it completes here table. Okay, divided difference table. By using this table, then write down the Newton's general interpolation formula. Okay, so by Newton's general interpolation formula for divided difference. For divided difference is, so write down formula here, f of x is equals to f of x naught plus x minus x naught into f of x naught comma x1 plus x minus x naught x minus x1 f of x naught x1 x2 plus x minus x naught x minus x1 x minus x2 into f of x naught x1 x2 x3. Stop here only, because our last entry is here third divided difference here. Okay, stop here only. Next, then substitute f of x as it is. F of x naught value we have a 10 plus, then keep x as it is, because we are going to find here interpolating polynomial in terms of x. Then you have to keep x as it is. Okay, x minus, if they ask interpolating polynomial, keep x as it is, keep it in a mind. This is very very important. If they ask a interpolating polynomial, then you have to keep a x as it is. Okay, so keep x here as it is. X naught value what we have here 2. Okay, then f of x naught comma x1, what we have of x naught comma x1, f of x naught comma x1 means 43. Okay, so write down here 43 minus plus x into x minus x naught 2, x minus x1, x1 value what we have here 4, f of x naught x1 x2, observe the table, then f of x naught comma x1 comma x2 value 19 plus x minus x naught x minus 2, x minus x1 x minus 4, x minus x2 value, okay, x2 value what we have 5, so x minus 5 into f of x naught x1 x2 x3, that is 2. You can observe the table. Okay, then solve this whole term. Okay, see here 10 as it is. Observe these 3 terms, this one and this one. So here x minus 2 is a common now. So in these 3 terms x minus 2 is a common, take it outside. Then what we have here 43 plus, take x minus 2 outside, then it becomes x minus 4 into 19 plus, take x minus 2 outside, then it becomes 2 into x minus 4 x minus 5. Then 10 as it is, x minus 2 43 plus x into 19, 19x minus 4 into 1976 plus x minus 4 into x minus 5 here. Okay, you can observe like a see x minus 2 as it is. What we have last term, x minus 4, x minus 5. This into this one, this into this one. 2 as it is, x into x, x square, x into minus 5, minus 5x, minus 4 into x, minus 4x, minus into minus, plus 4 into 5 is 20. Then 2 into x square, minus 5x, minus 4x, minus 9x plus 20. Then multiply 2 to these 3 terms. Then 2x square, minus 2 9s and 18x plus 40. Okay, substitute here directly. 2x square, substitute this value here directly, minus 18x plus 40. Next, 10 as it is, x minus 2 as it is, 2x square as it is, this term as it is, this is a single term, keep it as it is. Next, plus 19x minus 18x, x only, 43 minus 76. Okay, so what we have here, 43 minus 76 plus 40, 7 only, plus 7. Then 10 as it is, then multiplier, x to these 3 terms and minus 2 to these 3 terms. Okay, so what it implies, x into 2x square, 2x cube, x into x, x square, x into 7, 7x, minus 2 into 2, minus 4x square, minus 2 into x, minus 2x, minus 2 into plus 7, minus 40. Then rearrange the terms in a decreasing order of the power of a x. 2x cube plus x square minus 4x square minus 3x square, 7x minus 2x plus 5x. Then finally 10 minus 14 minus 4. Okay, so this is our required interpolating polynomial by using the Newton's divided difference. So this is our required final answer.